Okay, let's start talking through this stuff. Like I was saying before, it's kind of builds off of yesterday's lesson. So what yesterday's lesson was is it's the inequality stuff that we started the chapter off with. So inequalities like less than, greater than signs, that kind of thing. But instead of graphing them on just a normal number line, what they're going to do is they're going to give you like more like an equation that you would graph on like a normal like coordinate plane graph. So you have your graph here, you'll have your line or whatever that you're graphing. And then because it's the inequality, what you're going to have is you're going to have to do your shading, whether it be on like the top or on the bottom. So like say we shaded there. So that was kind of yesterday's lesson, is basically graphing a line and then doing some shading. What today's lesson is going to be is it's going to be a combination of that where we graph it and then do shading with the inequalities, but it's also going to be a system of equations. So system of equations is when we have multiple lines that we're graphing, and we're seeing where they cross each other. So like we'd have like another line, going across here, maybe something like that. And then maybe our shading was there. So the spots where it's double shaded, so it got shaded by both of those things, that's what we're looking for. Those are our solutions, okay? And that's called the feasible region, is the set of solutions that works for that. So like my area there, like right in there, that I had as double shaded, that would be considered the feasible region, okay? And then the vertices of a feasible region are basically your corner points where your boundary lines cross each other. So in this case, there'd be like a vertice right there because that's where our boundary lines cross. And you'll see some of those when we go through the examples. And then for like the steps for graphing these inequalities out, first thing you want to do is you want to graph out your boundary lines. So whatever equation they give you, or I guess it's an inequality because it'll have the less than greater than signs in it, but you want to graph that out. Figure out where you're doing your shading, whether you're doing your shading on the top, bottom, right, left, that kind of thing. And then with that, you're looking for, well, like I said, the double shaded region, or like the feasible region is the double shaded area. And then it's either going to be shaded or it could also be lattice points. Lattice points from yesterday are spots where it's like whole numbers versus decimals usually. Like if we're talking about people, can we have decimals of people? No, we can't, right? So if we can't have decimals of people, instead of doing shading, we just do dots instead. But we'll kind of talk about that as we're going here. Okay, so first example in our packets there. It says School Social Club is holding a flower sale. They will sell baskets of geraniums and petunias and plan to sell all of the plants that they have. Their profit on each basket of geraniums is $4, and on each basket of petunias is $2.50. If the club wants to profit of $500 or more, how many of each kind of flower should they sell? Okay, so the first thing we're going to want to do here is we're going to want to set up our system. Okay, so we've got flowers we're selling here, and we've got the price of those flowers, right? So for flowers we're selling, we've got geraniums and we've got petunias. I'm just going to make the geraniums a G, petunias P. It doesn't matter what order those are in, I just put them in an order. Okay, and they say that the geraniums, you're making a profit of $4, petunias $2.50, and they want the profits to be $500 or more. Okay, so if I take each of my geraniums, I sell times $4, so 4 times my geraniums, plus I take $2.50 times my number of petunias I sell. I want that to be $500 or more. Okay, so I'm going to have my 500 off to the side there. If I want to be bigger than 500, which way should I eat? Towards this other stuff, right? Because I want my profit, to be bigger than 500. And it says 500 or more. So should we include the line or not?
Oh, wait, yeah.
Yeah, we would, because it's 500 or more. So 500 would work for that. Just put that line in there. Now the other thing we have to account for here is kind of like thinking about like negatives. Like, are we going to sell a negative amount of flowers? No, that doesn't make sense, right? So with both of those values, because both of those values are flowers, we only want the positives there. So however many geraniums we sell, we want that to be greater than or equal to 0, because technically we could sell 0 of them. That would kind of suck, but we could sell 0. And then same with our petunia value there. we would also want that to be greater than or equal to 0. Okay, so that's our general just system for this. So again, it's systems like we were working on before, except for instead of equal signs, it's those inequality signs in there instead. So now what we've got to do is we've got to graph these to basically see where our sections cross each other. To be able to graph this first one, it's kind of in a not great, situation there. Couple ways you could do it. You could either solve it for, usually we solve it for like y equals everything else. In this case, our y is the p, so you could solve it for p is equal to, or whatever symbol in between, and then everything else on the other side. The other thing you can do is like the x and y intercepts. I'm going to go with that route, and I'll show you that here. So I'm going to start with my p-intercept. Okay, so my p-intercept would be, and that's on my y, so basically it would be wherever it's crossing right here. So that would be, if it's p-intercept, that would mean my g value would be 0. So basically you're putting in a 0 for the g and then figuring out what your p value is. So if I take that top equation there and I do that, I put a 0 in for the g, it would be like 4 times 0 plus $2.50 times p is greater than or equal to 500. And really, you could just make those equal signs there because you just need the crossing spot. Up to you. Sometimes it confuses people when I switch signs. Sometimes it confuses people when I use the other sign. So probably confused either way. Okay, but what's nice about these here is since that's times 0, that just cancels itself out, right? So really, we've got like 2.5 p is equal to 500, and then to get rid of that 2.5, just divide by it like we always do. And that's gone, so we'll have p, and again, you can either go equal there, or you can put the other symbol, it doesn't really matter. And then 500 divided by 2.5 is 200. So then what that would give us for the ordered pair, it'd be 0 for like our g value, or kind of like the x value, 200 for the p, so it would be like 0, 200 as our crossing spot. And then you would just do the same exact thing with your other flower there, so we'll want the geranium's intercept, or the g intercept. So with this one, since we're trying to find the g, we make the p as 0 this time, so it would be like g, comma, 0. And then you just do the same exact thing, but you're just going to put the 0 in for the p spot. So it would be like 4 g plus 250 times 0 is equal to 500, or again, you can put that other symbol there, it doesn't matter. Okay, so then that's going to go away because that's 0, so then we'll have 4g is equal to 500. Again, to get rid of, multiply by 4, divide by 4 on each side. 500 divided by 4 is 125. So then that order pair, again, it would be the 0 in that second spot. Figured out our g was 125. So it would be 125, 0 as our crossing spot. Okay, so then what we're going to do is we're just going to graph that out. So graphing here, these are pretty big numbers. I counted by 25s on my sheet, and that seemed to work pretty well, so I'm just going to do the same thing with you guys here. So let's just count by 25s each way. So 25, 50, 75, and so on. And then just do the same the other way. Count by 25s. And then based on how we set up our ordered pair earlier, again, it doesn't matter which one you do first unless they specifically say one way or the other. But our g was the x value, so that's going to be going across the bottom, and the p is in the y spot, so that's up the side. So I'm just going to label that side one as g, and that is p. Or you could do it as like number of geraniums. I don't know if I spelled that right, but good enough. And number of petunias. Okay, so anyways, so now what we want to do is we want to actually graph those out. So I'm going to start with that top equation there, and this is where I'm going to use the colors. You don't have to use colors, but sometimes it helps me to visualize what's going on. So here they want us to do the 4G plus 2.5p is greater than or equal to 500. And again, we found those intercept points there, so we can use those for our graph. So like 0, 200 would be over 0 and up 200. We'll stick a point. And then the other one is 125, 0, so you go over to 125, up 0 and stick a point. And then the nice thing with that is if you do the intercepts, then all you gotta do is you gotta connect them. Before we go to connect them here, from yesterday's stuff, if this is an equal sign underneath, is that solid or dashed? It's solid. So anytime it's equal to, that's solid, just like a closed circle. Okay, so solid line and closed circle are similar. So when we do it here, you're basically just going to connect between the 200 and the 125, and it's going to be a solid line because it's equal to. Okay, because everything on that line will count as being equal to 500, basically. Okay, and then shading wise, what we want to think here, so we've got this equation, we've basically got to figure out if we're going to shade the top side of that line or the bottom side of that line, okay? To do that, what I typically do is I pick out a point to plug in. Typically I use 0, 0 because that's usually pretty easy to locate on a graph. So what I would do is I would take 0, 0, I would plug it into that equation, so like 4 times 0 plus 2.5 times 0 is greater than or equal to 500. Well, if that's 0 and that's 0, wouldn't that be 0 is greater than or equal to 500? And is that true or false? Is 0 greater than or equal to 500? No, it is not. So if that doesn't work out, do I want to include 0 or do I not want to include 0? You don't want to include 0, right? Because if that didn't work, I don't want 0, 0 in my shading. So my shading would be on the top part of that. I usually do lines. You can shade it if you want to, just like scribbles. I usually just do lines because we're going to have to do some other shading here as well. Okay, so now we've got that top one taken care of. Now we've got to graph these other guys out here. So that one was that color that I was using. Okay, so now I'm going to switch colors. And again, if you don't want to switch colors, that's fine too. But I'm going to use a different color here, and I'm going to do my G is greater than or equal to 0. Okay, so with these ones, when it's just a letter like that, that's like our horizontal or vertical lines. So in this case, if it is G is greater than or equal to 0, that's basically going along this line here, our G, and it's saying all of our stuff that's bigger or equal to 0 there. So basically what that is it's just a line going across that G axis there, or like the X axis. And it's a solid line because, again, it was equal to there. Okay, so we'll have that line going across there. And then if we want all our values that are greater than or equal to 0, where do we find things that are greater than or equal to 0 compared to that line, do you think? Above it, right? So with our shading for this one, you're shading above it. Okay, and then we're just going to do the same exact thing with our P is greater than or equal to 0. So again, I'm just going to do a different color here so you can kind of see it. So there, if it's P is greater than or equal to 0, that's basically saying all of our P values going this way would be greater than or equal to 0. So I'm going to do my line across there. Actually, I think I have my colors backwards. I think this one's actually purple and that one's green. I think I'm saying them opposite. But either way, it's basically just cornering off that section. It's not super important. But again, it's our stuff that's greater than or equal to 0, so that is our stuff kind of going across that way. So these graphs get super, super messy because obviously there's lots of shading and lots of lines and stuff going on. But basically what you're looking for is you're looking for the sections that were shaded by every single graph we did. Okay, so where are we finding stuff that's like shaded by all three? Yeah, so kind of above this line here. And if you want to, sometimes what I'll do is I'll like extra darken it up here on the stuff where it actually is, just so I can remember that that's the stuff where it's actually, you know, doubling down and crossing. So those would be possible solutions to our system here, right? So basically those would be values where our profit is going to be greater than 500 bucks, because anything on that line is 500, anything past it would be greater than. And then to get our totals there, our geraniums has got to be greater than or equal to 0, petunias has got to be greater than or equal to 0. So that's why our shading is going up in both those ways. So you want that double shaded area there for your solution. So basically any value in there, so like if you had some sort of point in there, you know, anywhere, a spot in there, those would all be values that would give you a profit of greater than 500 bucks, okay? Now, technically here, I want you to add a little note to this. Technically, it's not completely shaded here because, like we talked about before, can you have partial numbers of petunias and geraniums? No, you can't break a flower in half and then sell half a flower, right? That would be silly. So technically here, I want you to put an arrow, and I want you to write that this is supposed to be lattice points. And then I would write not actually fully shaded. The reason that it's hard to do it on this and I just write lattice points instead is, would it be easy to go through and put every single point that's possible there? Like, you know, like between like 125 and 150, there's 25 points there. Would it be easy for us to put 25 little points in there and then do that for every single one? No, that wouldn't. If there's fewer, so like say it was like on this side of it, or it was something that was smaller and easier to count by, you could go through and put those points. If it's ever something like this and there's like so many that it's not very easy to do, you can just draw a couple of those points, kind of like I got there, and then just write a little note to me that it's supposed to be lattice points, because I understand that it's very hard to go through and put every single one of those little dots down, okay? And we only use that when it's got to be stuff that's like whole numbers or there's like a restriction with it, okay? Okay. Let's look at this next one then. Okay, so this one, they give us our system, which is nice, because then that makes it a little easier for us to just solve out. So then it says graph the solution to the system by hand, and then what are the vertices of the feasible region. Okay, so we're going to do the same thing where we just graph this out. Now in this case, these are actually set up where they're like y, and then everything else is to the other side, so we can use like slope and y-intercepts on these if we want to, instead of doing like the x and y coordinates. Really, it's just personal choice, but the way this one's set up, it's probably going to be easier to just do it as slope and y-intercept. So if I'm looking at that first one, well, maybe we should label our stuff here. So it looks like that's going to go up to 12. The graph here only goes up to 10. You want to count by 2s? Going across each way? Okay, let's count by 2s. It's probably a little aggressive, but 2s is fairly easy to count by. Okay, so I'm going to do this one in a color. So we got y is less than or equal to negative half x plus 6. Okay, so let's start with our y-intercept of that one. What's our y-intercept of that? The 6, right? So we're going to go up to the 6. We're going to put a point on our y-axis. And then our slope is negative a half, so what's that mean? Down 1 and over 2 to the right. So we're going to go down 1 over 2. Now technically here this is going down 2 and over 4, but because we counted by the same thing each time, it doesn't matter. You could also go down like half a space and then over 2. That would match up too. But you'll just do that a handful of times. So go down 1, right 2, down 1, right 2. You should end up at like the 12. Can you do that? Okay. And then looking back up at our thing here, if that's an equal to, line underneath, is that going to be solid or dashed? Solid. So we'll just make a straight line from the 6 to the 12, basically. Okay. And then shading wise, again, I like to do the 0, 0 thing. You don't have to do that, because so it's y is less than or equal to negative a half x plus 6. So usually what I do is I plug in that 0, 0. So like 0 is less than or equal to negative a half times 0 plus 6. So then we know that times 0 is just 0. So then it would be 0 is less than or equal to 6. Is 0 less than or equal to 6? Yeah, so if it does work, where should I shade? Underneath, right? Because I would want to include that 0, 0 in my shading. So we'd shade underneath that line. Okay, and then we'll just do the same thing with our next one there. So y is less than or equal to negative 2x plus 12. So what's our y-intercept of that one? 12. So again, I'm going to switch colors here. Go to 12. Put my point there. And then if it's slope of negative 2, what's that mean? And? We're going down 2 and over to the right. So down 2, right 1. And again, we're counting by 2s, but it shouldn't matter. Down 2, right 1. And that'll take us down to the 6. Then we're thinking solid or dashed. Solid, because it's equal to, so just a solid line from the 12 to the 6. And then again, I like to do the 0, 0. So if I go 0 is less than or equal to negative 2 times 0 plus 12. Again, the zeros will go away there. So now if 0 is less than or equal to 12, what do we think? Yep, it is. So where should we shade? Yep, on the inside or kind of underneath there, right? Okay. Alright, so then the next thing here, we've got our x is greater than or equal to 0. And I said this wrong before. Your x greater than or equal to 0 should actually be a vertical line going across there. I had them backwards. Again, it's not going to matter because they're both greater than or equal to 0. But here for the x is greater than or equal to 0, it's actually from here out this way. So my line is actually the vertical line. Like I said, sorry, I had those backwards before. And again, it's going to be solid there because it's equal to. And then if it's greater than or equal to 0, where do we shade? To, yes. Yeah, to the right. Yep, so everything to the right. Shaded for that guy. And then our y equals, or our y is greater than or equal to 0. Again, I had them backwards before because it's everything above the 0 for the y-axis. So it's just going across the bottom there. And again, it's a solid line because they're equal to for all of those. And then if it's y is greater than or equal to 0, where do you think we're going to shade compared to that line? Above it, yeah. Okay, so then same as before, we're looking for our area that's shaded by every section we did there. So what's our section that's shaded by everything? Yeah, in this little corner here, right? So again, if you want to kind of darken that up, sometimes I'll go back and do that just so I know that that's my little area that I'm looking at there. And then that little section that we just found, that's called the feasible region. So if they say something like, hey, find the feasible region, that double shading area, or in this case, quadruple shading or shading with all 4 there, that's our feasible region. Then the other thing they want us to figure out is what are the vertices of this feasible region. The vertices are basically just your corners of that section that's shaded by everything. So here we've got a corner right there, there, and there. So those 4 spots there that are kind of like the edges of that area that's double shaded there, those are our vertices. And we'll just list those out because it says what are those vertices. So our vertices, we're going to have one here at the very corner at 0, 0. We've got one here at 6 and then 0, so 6, 0. We've got another one here at 4, 4. And then our last one there is at 0, 6. So those are called your vertices. So basically you're just doing your graphing, and then you're just seeing what's in the double crossed area, or quadruple crossed, or whatever, okay? And the extra shaded parts, feasible region, corners of that are the vertices. If they just ask for a general solution, solution is anything in the area that's like shaded by all of the stuff, okay? So that's it for this section here. So working on that book page for tomorrow, and then tomorrow's stuff is going to build off of what we were doing today with like the feasible regions and the vertices, okay? So working on that book page.